So we've talked about vertical asymptotes, we've talked about x-intercepts, and also horizontal asymptotes. The purpose for this specific definition is to kind of give you a more comprehensive viewpoint of those horizontal asymptotes. As you can see, there can actually be no more than one horizontal asymptote. So on your graph, there should really only be one. Now, the thing that's a little bit tricky with horizontal asymptotes is that they can actually have an asymptotic crossing. I know in the past what I've told my students is to consider asymptotes as like that electric fence, but with horizontal asymptotes, there actually can exist a crossing. It's seldom that it happens, but it can happen. Now, for example 2, we're going to kind of run through the 3 different scenarios that we see with horizontal asymptotes. So, for just looking at this first one, it's asking, find the horizontal asymptote for each. F of x is equal to 1 over this x plus 3. Well, we can see that the degree on the top is smaller than the degree on the bottom. On the bottom, we actually have 1. On top, we just have some constant number. We don't even have an x at all. So this is just some constant, and as a result, oops. We have some constant on the top, and we actually have a degree of 1 on the bottom. And as a result of that, if we think back to the 0.2 set of notes, when we ran into that issue where the degree on the bottom is larger than the top, then we end up with that horizontal asymptote just coming out to be y equaling 0, at least just for the rational function part. You know, if maybe it had some k value over here, you would tack that on. But here, we really don't. It'd be plus 0, so it's not changing our horizontal asymptote at all. For this second scenario, we notice that we have the function 4x minus 1 on top over 2x plus 3. Here they actually have the exact same degree. They're both 1. And anytime we end up with that event where the degrees are exactly the same on the top and the bottom, all we have to do to find our horizontal asymptote, all we have to do is go ahead and divide those leading coefficients. So 4 divided by 2 just comes out to be 2. So that would be our horizontal asymptote. Now for the last one, we have the function x squared plus 2 all over x minus 3. And as you can clearly see, the degree on the top is larger than the degree on the bottom. And when that actually occurs, we actually will have no horizontal asymptote. All right? So just kind of keep that in mind. If that's the third scenario we haven't had a chance yet to talk about. If the degree is on top is larger than the bottom, you won't have a horizontal asymptote. So again, that is example 2 from the 0.2 number 2 set of notes.